Today we will discuss about BSc Mathematics topic Riemann integrals. Okay, so in this topic we need to discuss about intervals like partition of intervals, norm of intervals, okay, refinement of intervals, and upper sum, lower sum, and many things. Okay, so in this first point, partition of partition of closed interval AB, closed interval AB. Suppose one line is there like number A and number B. So closed interval means including the endpoints. Okay. So this called closed interval. Open brackets called open interval. Okay, so in this topic we need to discuss about closed intervals, okay, like A and B. So partition means we need to split these intervals in nth terms, like here it is x naught, here it is sorry here it is A is equal to x naught, x1, x2, x3, and so on. Let's say xr and so on. There are number of subintervals like xn is equal to b. Okay, so that means this one subinterval is, there are number of subintervals like n number of subintervals in this particular interval, closed interval AB. So here it is. So condition is like this: A is equal to x naught is less than x1, x1 is less than x2, x2 is less than x3, and so on, which is less than xr, and xr is less than, and so on, xn. What it mean? What it means? So it is means we have to make partitions like small partition or small intervals, subintervals in this closed interval AB. So like this, we need to take partition P. We need denoted as P partition. Okay. So first interval is x naught and x1. So here it is x naught comma x1 is one interval. Again x2 comma x1 comma x2 another one interval. Again x2 comma x3 another one interval, and so on and so on. Here it is xr minus 1, comma xr, and the last one interval is xn minus 1 comma xn. Okay, these are our intervals. Okay, so that means the partition means we have to split the whole interval in their subintervals like x naught x1, x1 x2, x2 x3, xr minus 1 xr, xn minus 1 xn, like this. So this type of representation of particular closed interval called partition of interval, and it is denoted by p. Okay, partition of interval is denoted by p or I. Okay, so what it means, here it is x naught comma x1, here it is there are subintervals. Okay, these are subintervals. Okay, and it is denoted by it is denoted by delta r. Okay, delta r is equal to xr comma xr minus 1 comma xr. Okay, xr, that means we need to represent this interval like delta r. So what we going to discuss about this first interval, we can say delta 1 like x naught comma x1 is our delta 1, delta 2 x1 comma x2 our delta 2, delta 3 x2 comma x3 is our delta 3, and so on and so on. Delta n is equal to xn minus 1 comma xn is our delta n. Okay, so here it is what delta r means or delta n means, our sub intervals of the partitions. Here it is delta n r, therefore delta n's are our sub intervals of given closed interval AB. Okay, so this is the concept of partition of AB. Okay, so then next we need to show that norm of partitions. Next concept is norm of partition. Norm of partitions means length of that particular subinterval called norm. Okay, it is denoted by norm p. Okay, this notation called norm of p. Okay, which is equal to length. Okay, so usually we can define the length in absolute value. So absolute value. Okay, so how are you going to distance? Okay, a and b. So absolute value of b minus a is our norm. Okay, norm of given in partition, right? So we can represent final term b minus initial term a. We will get length of that whole interval, but we need norm means greatest length of subinterval. Okay, subinterval called norm of interval, right? So what it means, norm p is exactly equal to absolute value of xr final term minus xr minus 1. Okay, so we don't know which interval will come here because we need to find the greatest length of this interval. Okay, so it may be this or this or this, we can't say like. Okay, so we can generally represent xr minus 1 and xr is our interval, and that length of this particular interval is final term minus initial term. Okay, so here it is absolute value of xr minus 1 is our norm of the particular given partition P. Okay, so I hope you clear these two concepts, partition of closed interval AB and norm of partition. Okay, so in this is the basic fundamental concepts of Riemann integral topic. Okay, thank you.